We can now look at how an airplane can manage to fly in total aerodynamic balance, known as being in trim. A force acting remotely on an aircraft's center of gravity produces a torque around this point. Torque is defined as being a force that tends to cause rotation in an object, and is considered to be a twisting force. When an aircraft changes its motion or direction in flight, it is effectively rotating around its center of gravity. When an aircraft has a constant motion, there should be no torque around the center of gravity. When this occurs, the aircraft is considered to be trimmed, or configured to allow for balance and stable flight to occur. In most cases, airliners have their center of gravity near the center of pressure of the wings. If the center of pressure is located rearwards in relation to the center of gravity, then the torque around the latter is anticlockwise, and is caused by the amount and distribution of the lift generated. Generally, positive lift creates anticlockwise torque, while negative lift creates clockwise torque. In order to trim an aircraft, a balance must be found between the lift generated by the wings and tail. If both produce positive lift, then the aircraft is impossible to trim, due to two anticlockwise torques being created, and not being able to cancel themselves out. Therefore, if the wings produce a positive lift and create an anticlockwise torque around the center of gravity, then the tail must produce an equivalent but negative lift, counteracting the torque with the clockwise twisting force. This would lead to no net torque being present around the center of gravity. We can now look into the characteristics of an aircraft's motion, as well as the physics behind various changes in such movements. Ideally, an airplane is in constant motion if both the vertical and horizontal speeds are both equal to 0, which means the four forces are balanced and cancelling each other out. An imbalance in such forces is what leads to changes in altitude, speed, direction, and motion, as implied by Newton's first law of motion. An aircraft can change its attitude in 3 dimensions or axes, which all use the center of gravity as their origin. The motion of an airplane is caused by the amount of rotation around these 3 components. Yaw is the motion of the nose from side to side, and is the vertical axis which passes exactly through the center of gravity. Pitch is the nose's vertical motion, and is the lateral axis that passes through the airplane's wings. Roll is the vertical up and down movement of the wingtips, and is the longitudinal axis, passing through the nose and tail of the airplane. The flight control surfaces are able to change the aircraft's motion mid-air by producing the required aerodynamic forces. The elevators produce pitching moment, while the ailerons produce rolling moment, and the rudder produces yawing moment. In order to change the heading the aircraft is traveling in, banking turns are used, which are caused by the use of several aerodynamic devices. The turn is initiated by lifting one of the wingtips vertically, causing the other to lower. For instance, if a plane had to turn left, it would do so by lowering the left wingtip, and consequently elevating the right wingtip, with the opposite being seen in right turns. This occurs due to lift, which in level flight with no roll is perpendicular to the flight path and wings. When the wings tilt in a particular direction, the lift force also tilts into the roll, remaining perpendicular to them. The lift vector is composed of 2 parts, the vertical force and the side force. When an aircraft banks, the side force acts on the aircraft, causing the center of gravity to have a circular arc motion. The rudder is not directly used to turn the aircraft, although it assists in keeping the nose pointing along the flight path. The ailerons and elevators both work by modifying their shape, with downwards movements increasing their angle of attack and thus creating more lift, and upwards movements reducing their angle of attack and thus reducing the lift produced.